Hello. Welcome all. Wait, beta, wait. Few more seconds. Okay, we are live now. Welcome all, beta. Welcome all. Welcome all. कैसे हो भाई सभी लोग? How are you? Okay, beta. So now we are in lecture number 4. Another beautiful session of heat transfer operation new numericals. As you all know, this is Gaurav Sharvastu sir, educator at Gate Chemic Learning App, Gate Chemic Institute, with 11 plus years of teaching experience. Or without any delay, beta, we will start just after waiting 30 more seconds. Okay, we will start after 30 seconds. Okay, beta. So first, clear me, everyone. You're all welcome once again, beta. First, clear me. Audio and video is clear to all of you, beta. Very happy good evening, beta. Shunari, very happy good evening, Vivash. Okay, beta. So shall we move forward? Can we start, beta, with beautiful problem number 1 today? Are you all ready with your virtual calci? Everyone, please tell me, beta. आप सभी तैयार हैं? You are all ready with pen, notebook, and virtual calci. Please open virtual calci in another mobile. Okay, beta. So now, just write yes in comment section again, beta. If everything is okay to all of you. Okay. So now but I am proceeding with my problem number 1. Today's problem number 1 now in front of you, beta. It's very easy problem. So for this problem I am giving you just 4 minutes. Timer number 1 is started already. It's very easy problem, just need your basics. Nothing else. 1 minute completed, beta. Come on everyone. Last 12 second beta. Okay beta, timer number 1 completed. So now I am giving you hint. Okay, so hint क्या है बेटा? What is hint? Whenever you want to calculate net radiation exchange between two bodies, then in that case q net can be written as sigma t1 to the power 4 minus t2 to the power 4 divided by sum of all resistances. Now, in all resistances for radiation chapter, two resistances are there beta. One resistance is surface resistance and second one beta is space resistance. Surface resistance you can define as 1 minus epsilon upon epsilon A, where epsilon is the respective emissivity of the respective surface for which you are going to write surface resistance. जिस surface के लिए आप surface resistance लिख रहे हो, epsilon उस surface की emissivity है and A is area there. Now for space resistance you can write like 1 upon, like for between surface 1 and surface 2, if there is a space present, then you can write it like a1 f12, or this can also be written as 1 upon a2 f21, because we know by the rule of reciprocity that a1 f12 becomes equals to a2 f21. Okay beta, so now after this hint I hope now you are all able to solve this problem. Okay, so now I am again starting beta timer number 2. One more hint beta. Here convex part of hemisphere is insulated. You know beta what is convex? Which part of the sphere is convex? I am drawing diagram. Wait. If this is your hemisphere, if this is your hemisphere, then this part is insulated. This part is beta convex part. This is convex and the inner side is concave. So this is exchanging with a large enclosure. This is present in a large enclosure and exchanging heat with this large enclosure, this surface. Like you can write this inner side as surface number 1 and this large enclosure as your surface number 2. So I hope now you all will give me answer. You all can give me answer. Come on beta, everyone. Last 100 second. Come on beta, everyone. Last minute beta. Last 40 second beta. Manthan 619. Beta, it is not correct. Try again, beta Manthan. Check it again. Maybe you are correct. I will check. But according to me, answer is different. I will calculate again if there is any error while during calculation by me. Okay. So now, better pay attention here. See, I can't give you more time. Okay. So it's very easy problem beta. Here you can see this is your convex part and this inner side is maintained at 427 degrees Celsius. That means first you have to convert this into 620 is also you both got 620, then maybe 620 is correct. Please give me a few time beta. I will calculate it again. Okay. Now see here beta. The oh wait, where is one two one two oh one data is missing. But can you tell me? Here you had used this one F12. What is the value of F12 beta? Can you tell me what is the value of F12? Please tell me everyone beta. What is F12? Can you tell me beta what is F12? Please everyone beta tell me what is F12. Is it one? Is it one? Beta how you can take one beta? It can't be one na. It can't be one because here you can see radiation can go in any way. So you can see one is also there. So if f11 is not 0, then how you can write beta f12 is 0? Is it crystal clear to all of you beta? Okay. Now, sorry, but one misprint by me typing error. So this is concave. This is concave. Okay. So now please beta, I am giving you again few time. Try to solve it again. Okay, for 2 minutes. I will wait for 2 minutes. Okay, but now start solving. Because in that manner, F12 is missing in your problem. No, here in this case, beta, you can see F12 you can take it like 1. You can take F12 as 1 and this surface is at 700 Kelvin, 27 degrees Celsius. That means 300 Kelvin. Enclosure is at 300 Kelvin. And these are exchanging heat. Okay, so I hope now you all will give me correct answer. Okay, solve it with a quick, fast. Very good, beta. Absolutely correct, Manthan. Very good. Last 30 second, beta. For that typing error, only 2 minute extra, beta, because after everything I already discussed fundamentals of this numerical, so 2 minute is more than sufficient. Last 5 second, beta. Okay, beta, time up. Now pay attention here. No problem. See, so in this case, beta, you have to calculate Q net. Okay, and for Q net, you know the formula, that is T1 to the power 4 minus T2 to the power 4, and T1 and T2 must be in Kelvin, beta. Now in this case, beta, you can see there are three resistances are there. One here surface resistance, second space resistance, then that large enclosure surface resistance. Okay, that means first one is surface resistance of convex part, that is 1 minus epsilon 1 upon epsilon 1 A1 plus space resistance, you can write like F A1 F12 plus 1 minus epsilon 2 upon epsilon 2 A2. So this formula you have to use, beta. Now you know now this is the case of large enclosure. If large enclosure is given there, if large enclosure is given there, that means A2 tends to, beta, what? A2 tends to infinite now. So this term you can write as 0. Okay, after writing that part as 0, now your equation becomes, our above equation becomes sigma, and I'm also taking this a1 common from this denominator part. Okay, denominator of denominator. So here I can write above equation as sigma a1 t1 to the power 4 minus t2 to the power 4, and whole divided by, beta, 1 minus epsilon 1 upon epsilon 1 plus 1 upon f12. Now just put all values, beta, you will get your final answer. So sigma is Stephen Boltzmann constant whose values 5678, that means 5.67 into 10 to the power minus 8 watt per meter square per Kelvin to the power 4, and area for hemisphere surface, that means 2 pi r square. So it's 2. I'm writing pi as pi because in virtual calculus there is an option to write pi. Okay, so 2 pi. And what is r? R is also there, beta. Where is r? 20 centimeter dia. That means r is 10 centimeter. 10 centimeter means 0.1 meter. Okay, so 2 pi r square, and t1, that was 700 to the power 4 minus 300 to the power 4, and whole divided by, here you can see, beta, 1 minus zero point 0.5. MSFT is also given in our problem, and F12 is 1 here in this case only. Now you can see, beta, this denominator term 1 minus zero point 0.5 will give you zero point 0.5, and zero point 0.5 by zero point 0.5 will give you 1, and this 1 plus 1 will give you 2, that means 2 is in denominator. You can cancel this 2 from this 2, and after solving you will get 413.05. Please confirm, beta, everyone. Solve it by your calci, beta, because in lots of time you can do कैलकुलेशन एरर. ओके बेटा, सो कैलसी से सॉल्व करेंगे आप सभी लोग. सॉल्व इट अगेन बाय यूजिंग योर वर्चुअल कैलसी एंड टेल मी कि आपको ये मिल गया. यू गॉट द सेम आंसर नियरली 413. ओके बेटा, 413.34 इज ऑल्सो करेक्ट. यू आर इन द रेंज. एवरीवन टेल मी बेटा, इज इट क्रिस्टल क्लियर? शैल वी मूव फॉरवर्ड? क्या हम सेकेंड प्रॉब्लम की तरफ जा सकते हैं बेटा? एवरीवन प्लीज टेल मी. शैल वी मूव फॉरवर्ड टू प्रॉब्लम नंबर 2 बेटा? If you have any doubt, then please beta feel free to ask me. Otherwise, please write CC in comment section. Crystal clear, sir. You want explanation again, beta Chetan? Okay, no problem, beta Chetan Dile bro. See here, in this problem, it is written that the 20 centimeter diameter hemisphere is maintained at a constant temperature of 427 degrees Celsius. That means, beta, this is beta, you want explanation in Hindi or English? जो भी repeat कराना चाहता है, please tell me your language. हिंदी ओके बेटा। तो यहाँ पे आपके पास बेटा 20 सेंटीमीटर का डायामीटर का हेमिस्फीयर है, जो एक कांस्टेंट टेम्परेचर 427 डिग्री सेल्सियस यानी कि 700 केल्विन पे मेंटेन किया गया। इसका कॉन्केव पार्ट जो है हेमिस्फीयर का बेटा वो इंसुलेटेड है। ठीक है, अभी एमिसिविटी सरफेस की दी हुई है, यहाँ पे जो आपका सरफेस है इसकी एमिसिविटी आपके क्वेश्चन में 0.5 दी हुई है। ओपनिंग जो यहाँ पे ओपनिंग है, मतलब अपार्ट फ्रॉम दिस इंसुलेटेड सरफेस जो ओपनिंग है वो आपकी रिटेंट एनर्जी को एक्सचेंज कर रही है विथ अ लार्ज इंक्लोजर that is present at 27 degrees Celsius. If you are going to convert this 27 degrees Celsius in Kelvin, you can write with a 300 Kelvin. Now, just you want to know that the net radiation exchanges. So, for net radiation exchange, you know beta, in numerator, what is this beta? This is nothing but EB1 minus EB2. इन रेडिएशन नेटवर्क चैप्टर ये हमने आपको ऑलरेडी पढ़ाया हुआ है। अगर नहीं याद है कोई बात नहीं, आप सिंपल आपको ये फॉर्मूला हमेशा याद रखने का है कि फॉर एनी टाइप ऑफ बॉडी, इवन ब्लैक बॉडी है चाहे नॉन ब्लैक बॉडी है, इट डजंट मैटर। ओके, सो जस्ट राइट सिग्मा T1 पे 4 माइनस T2 पे 4 अपॉन इन डिनोमिनेटर सम ऑफ ऑल रेजिस्टेंसेस। साइड रेजिस्टेंसेस में क्या होते हैं? सरफेस एंड स्पेस। हियर यू कैन सी वन सरफेस रेजिस्टेंस इज देयर, वन स्पेस रेजिस्टेंस एंड दैट लार्ज इंक्लोजर, that large enclosure's second resistance of that surface resistance. Okay, but large enclosure का चूंकि बेटा एरिया बहुत ज्यादा होता है, एरिया A2 tends to infinite, that is why this term को हमने कर दिया neglect. Now this is your equation, just putting the value given in our problem, just उसको put किया, then I will get my answer. Is it crystal clear now beta? Shall we move forward to problem number 2? Okay, very good beta. So this is another beautiful problem, 2 mark problem you can say beta. Match the column. Match the column, sorry. Just tell me right sequence from starting from the leading edge. Arrange flow rhythms for the vertical convection layer is starting from the leading edge. That means flow over a flat plate is going there like, and the rhythms starting from the leading edge. First reason, second reason, third reason, fourth reason, fifth reason. Because 5 reasons are there. A, B, C or D. So Jewel told option C. Okay, beta. Wait for my answer. Everyone, please give me better answer. And if you want to left this problem, then just write L in comment section. Means आप एग्जाम में ऐसे क्वेश्चन को इसको नहीं अटेम्प्ट कर रहे, because minus marking is there, because option is there. So if you are confident, then give me answer. Ankit Verma C, Manthan left, Javel C. Okay. Tell me other students beta. Everyone please tell me beta. सभी लोग बताएंगे. 20 more seconds are there. Chinori left. Okay. No problem. Last 12 seconds. Okay, beta. So second timer is not available for this problem. It's very easy. If you know, then you can give answer. Now see here, beta. This is your plate from which vertical convection is takes place. That means convection in y direction. This is your plate. Width in z direction. By default, if nothing is there, you can write these as your coordinates. Okay. Now flow reasons. You know, beta. हमने आपको कराया था. I already taught you a beautiful derivation to obtain boundary layer thickness formula. Delta by x equals to 4.64 upon Reynolds number to the power 1 by 2. अगर आपको याद है, if you remember, then बेटा आपको याद है हमने आपको बताया था that in reality our boundary layer, thermal boundary layer is not starting from this leading edge. It is started some after some distance, very small distance. This distance is tends to 0. This x naught, if I am writing this distance as x naught beta, then this x naught is tends to 0. Okay, and this starting point is known as beta conduction region. This is known as conduction region because first heat is going to transfer to the fluid from this point via conduction first. So this is my conduction region. Conduction region. Once conduction region completed, after conduction region, your second region is asymptotic flow. Means this time flow is not called as laminar. After some distance, this is known as laminar flow. And after that, transition flow. After that, turbulent flow. So if you don't know beta, please note it down in your notebook. So now please tell me which one is correct. You can see CR, that means 3, first 3, and then asymptotic totic flow, then followed by laminar, followed by transition, followed by turbulent. It means D is the right answer. Okay, beta, is it crystal clear to all of you? Shall we move forward, beta? Okay, so now this another beautiful problem number 3. Oh my god, it's a beautiful 2 mark problem, and two part of this problem is there because to clear your full fundamentals, two parts must, you have to solve two part, you must solve two parts for this problem. So I will start timer after few seconds. It's very beautiful problem beta. Today I will not give you beta extra time, okay, because at least I want to discuss 10 numericals today, total number of 10 problems. Okay beta, so now I am starting timer number 1. I hope at least I got one answer in this timer. Last 30-second approx beta. I'm starting timer number 2. अरे थोड़ा एनर्जी ले आओ भाई, जल्दी जल्दी लगाओ, कितना स्लो लगाते हो आप लोग. ट्राई टू सॉल्व इट क्विकली बेटा. कम ऑन एवरीवन. रिवीजन इज नॉट गोइंग ऑन, रिवीजन नहीं कर रहा है कोई भी. बस सर जब आते हैं लगवाने प्रॉब्लम, बस उस समय आ गए घर पे, खुद सेल्फ प्रैक्टिस जीरो, रिवीजन जीरो. दैट इज व्हाई यू आर टेकिंग टू मच टाइम. I discussed this topic in lecture for at least 30 minutes, offline classes as well as in online classes. 30 मिनट तक आपको बताए थे शॉर्ट ट्रिक, बट स्टिल यू डोंट नो. आई एम नॉट हैप्पी विथ यू बेटा. किसी से भी खुश नहीं है. एक भी बच्चा जवाब नहीं दे पाया. इट्स नॉट गुड. 0.68 is absolutely wrong. You can give me time in second if I'm not mentioning there. But your answer in a second as well as in minute, wrong. Wait, I'm mentioning here the time. Second. Now pay attention here बेटा. Time over. अभी बहुत सारा क्वेश्चन ट्राई करने का है. No need to worry. Now see here बेटा. As I told you earlier in your class, online or offline class, आपको याद है? You know, first thing beta, no beta, 0.687 is not correct. First thing beta, see here, from a coal furnace, a flue gas stream is to be monitored for its temperature. That means you have a coal furnace from where a flue gas is going on, and its temperature is to be monitored by the using a thermocouple sensor connected to a data acquisition system interface with a desktop computer which displays the measured temperature. Okay, no data in these three lines. The thermocouple sensor is initially at 25 degrees Celsius. Okay, beta. So here it is given that the initial temperature of our thermocouple is 25 degree Celsius. Okay, good. And the thermocouple design needs to be evaluated in terms of its time response to accurately predict the measured temperature. Okay, thermocouple के सेंसर को इस्तेमाल करने का हमें ऐसा डिजाइन करना है कि वो एक्यूरेट टेम्परेचर को मेजर करे. द थर्मोकपल जंक्शन कैन बी अप्रोक्सीमेटेड एज अ स्पेयर ऑफ रेडियस 0.3 mm, यानी कि उसके जंक्शन को एक स्पेयर की तरह ये कह रहा है, आप एज्यूम कर लो, जिसका रेडियस जो है वो 0.3 mm है. प्लीज एज्यूम इट एज a sphere of radius 0.3 mm. Properties are constant and is independent to temperature. Properties of the Johnson are given as everything is there of Johnson. First, density is there, 8500, 8500 kilogram per meter cube, and second data K and Cp. K thermal conductivity is also there. It's 0.035 watt per meter per Kelvin. Okay, and no, sorry, K is 40 here. Sorry. K is 40. K is also there, 40. Next data Cp. Cp is also given in our problem. Cp is 0.35 kilojoule. That means beta, first you have to convert this into joule. So joule में क्या हो जाएगा? 350 joule per kg per Kelvin. Okay, completed. Beautiful. And the convective heat transfer coefficient between Johnson and the flue gas is 200. Okay, H is given as 200 in SI unit, 200 watt per meter square per Kelvin. Okay, beta. Now, you know now this is the case in which you have a sphere of 0.3 mm radius. So first, beta, you have to check what is the value of Biot number here. So it can be checked as Hs by K. The value of S for sphere, you know na beta. This is volume upon area, and volume upon area you will get how much beta? याद है आपको? After cutting everything, to save time, you must remember this beta, that V by A is, yes beta, it's R by 3. Okay beta, very good. So here you can calculate it like 200 into R is given as 0.3 mm. So multiplied by 10 to the power 3. Now R in meter upon 3, and K is there. K value is 40. After calculating, you will get, okay, Jewel told that 0.0001. Uh, Confirm beta, 0.0001. Tell me again. Everyone beta, is it correct? Point 0.3 divided by 3 divided by 40 divided by 1000. Beta, it's 0.00005. Okay, you are telling me about R by 3. Okay, okay, no problem. So buyout number is 0.0005, and you can see better this is much less than zero point 0.1. That means lumped heat parameter analysis, we can apply a lumped parameter. Okay, and for that analysis, अगर आपको याद है, so we can apply our that transient heat conduction equation, lumped heat analysis. Okay, lumped heat analysis. And in that case, अगर आपको याद है, if you remember, so the equation you got finally, हमने आपको याद कराया था. याद है कैसे याद कराया था? I told you that full temperature difference, that should be Ti minus T infinite, full path. This is your full path, and the path you traveled, that is T minus T infinite, and that becomes equals to e to the power minus HA by rho V Cp into T, and it can also be written as e to the power minus T by tau, where tau is the time constant known as time constant, and if T equals to tau, then we already walked through how much path? 63.2% path. And here in this problem you can see 63% of the initial temperature difference, यानी कि थोड़ा सा अलग है. 63.2 is different, 63 is little bit different. Okay, अगर 63.2 कहता तो आप सीधे सीधे you can calculate this tau directly, and your tau will be your answer. Okay, so you can see beta, this is your overall temperature difference, and this is, what is this? This is overall delta T. And what is this? This is delta T at time T. So here first he want to know that 63% of the initial temperature difference. That means beta, to solve problem number 3, 63%. To solve this problem number 3, you have to take this LHS as beta. How much can you tell me? LHS should be equal to, please tell me everyone beta, LHS should become equal to 0.63. Confirm ho beta? Are you confirm? You have to take 0.63. Here T minus T infinite, that means this is the path is still left there. Am I correct beta? Yes, it's 0.37 now. It's 0.37 now, because this is the temperature T. Suppose beta, initially this is at some temperature, like I'm assuming temperature is not mentioning in our problem, temperature nahi diya hai because we need no need of that data. Okay, उस data की कोई requirement ही नहीं है हमें, इसलिए temperature नहीं दिया हुआ है. Okay, so suppose I'm just giving you a typical data. A Ti is 1000 and this is 100. Suppose I'm giving you just in our problem it is 25. Okay, I'm writing 25. Suppose I'm writing in degree Celsius. Okay, and here after some time, It 1000, from 1000 it now becomes equals to 600. Can you tell me beta how much path? 63% of the initial, वहां आपसे कहा प्रॉब्लम में यहाँ, can you tell me how much path? It numerator shows what? Already completed path or left path? Because t will approach to t infinite. Left path na, this is left path. So to get how much path you already traveled, you must subtract this from 1 ना, आपको ये 1 से subtract करना पड़ेगा ना. Is it crystal clear? That is why I'm writing here 0.37. Please tell me everyone, but is it clear to all of you? If it is clear, then everything is clear. So minus h is there, h is 200, and I'm not writing a there. A v अलग अलग calculate करने का requirement नहीं है, no need to calculate separately. And rho is 8500, and v by a, हम a को नीचे लेके आ रहे हैं, v by a, so in place of v by a I can write r by 3. So r is 0.1, sorry 0.3 into 10 to the power minus 3, and r by 3 I am writing 3 here. ये हो गया, this cp is here, and the value of cp is 350, and here t. Beta, one equation, one unknown. Now solve it and tell me t. Come on everyone beta. Yes beta, it's absolutely correct, it's 1.48. And beta, tell me unit, second or minute? Second, because you had taken watt. Watt means joule per second. Okay. Zevel, which beta is this path you want to know? Explanation once again. Okay. Now see here. Okay, see here beta. Suppose here the case of cooling. Cooling is there. That means initially your body is something at temperature 1000, and just taking as a typical value. Okay, 1000 degrees Celsius, and your final destination will be equal to your surrounding temperature. Okay, then you will get a graph like this, exponential. Is it correct beta? Okay, now see, uh, this is your initial temperature difference beta, just tell me yes or no. This is your initial temperature difference, just tell me yes or no. Okay, now suppose this time you are here and this is 600, you are here and this is 600. Okay, can you tell me this time what is the value of temperature difference? You already traveled. Delta T you already traveled. How to get beta? The time, that 63, you can see here. It is written in your problem. 63% of the initial temperature difference. 63%. So here not 60, just I am writing this percentage. If you are here, I am writing like percentage, so that आपको अच्छे समझ में. रुको, इसको हटा देते हैं, हम परसेंटेज के रूप में कहते हैं. सपोज this time you are here beta, this time you are here, and this is your 40, suppose 40% path. Okay, so can you tell me beta, 40%, that means you already traveled now 40%? Just tell me yes or no. Okay, so while taking in your that problem, you had to take that LHS as what? कैसे लोगे उसे आप? This one ना. Is it clear? Okay, so this was your problem. Now tell me beta, second number answer, fourth one answer. Everyone. हिंदी में भी समझ लो. अगर 40 तक पहुंचने में आपसे पूछता है कितना टाइम लगेगा, तो ये 40 तक पहुंचने में आपसे यहाँ का टाइम पूछ रहा है, यहाँ का टाइम. ठीक है, आपसे ये वाला टाइम पूछ रहा है, तो इस टाइम पे क्या लोगे आप? अभी 40% जब पहुंचे तो इनिशियल का बचा हुआ लोगे ना बेटा, ये बचा वाला पार्ट लोगे ना, दिस इज योर बचा लेफ्ट, this is your left part ना, you can see this is t and this is t infinite, this is t minus t infinite. okay बेटा, so परसेंटेज ऊपर वाला दिया है तो आप लोगे क्या, नीचे वाला लोगे. इज इट क्लियर? if you have still doubt then you can ask me again बेटा, हिंदी एंड इंग्लिश आप किसी भी लैंग्वेज में पूछ सकते हो. फॉर रिवीजन जस्ट राइट आर एंड ई फॉर इंग्लिश, एच फॉर हिंदी. Very good, Manthan. Very good, Chinnari. 6.85 is absolutely correct because this time your LHS should be 0.01. Why? Because 99%. You all already traveled 99% path. That means this left path will give you T minus. This left path will give you T minus T infinite. This is traveled path, beta. This is traveled path. Okay, so this left path will give you t minus t infinite. So if traveled path is 99%, that means left path is 0.01%. Oh, sorry, 99%, that means 1%. So 1% in fraction 0.01. And here e to the power minus h was 200. Same thing. You have to write again. RHS will be same. RHS आपका एक बार फिर से वही रहेगा बेटा. Just LHS चेंज हो जाएगा. After solving beta, you will get 6.85 second. Absolutely correct. Now beta, please tell me fundamentals are clear. ये topic crystal clear हो गया आपका. Shall we move forward to another beautiful numerical? Are you all ready beta? Are you all enjoying the class? मजा आ रहा है? Shall we move forward बेटा? सभी लोग बोलोगे, फटाफट बोलो, जल्दी जल्दी. Everyone बेटा. Shall we move forward? Okay. So now I am giving you a beautiful small problem. Just tell me बेटा, 1 mark problem भी एक आ गया बीच में ताकि आपका सिर थोड़ा हल्का हो जाए. फटाक से बोल दो ABCD. टाइमर स्टार्ट नहीं होगा. Just give me answer. You have 30 seconds approx. Come on बेटा. जल्दी बोलो everyone, please tell me. Jewel C. Manthan C. Confirm बेटा. विभास C. चिन्नारी A. देखो इतना आसान क्वेश्चन था, सब गलत कर दिया. चेतन दिलीप राव A. Absolutely correct बेटा. Rayleigh's number is defined as a multiplication of Grashof number and Prandtl number. This Grashof number is equivalent to which number beta? Reynolds number. And Reynolds number into Prandtl number you know as which number? Can you tell me beta? This one, which number? Reynolds into Prandtl. Reynolds into Prandtl, which number? Packlet number. So Packlet number is analogous to this Rayleigh's number. Is it crystal clear to all of you beta that A is correct? देखा, हमको पता था आप मिस्टेक करोगे. दैट इज वाई ये छोटा सा क्वेश्चन बीच में लगाया आपके लिए. ठीक है, बिकॉज 1 mark प्रॉब्लम भी तो आता है ना. सो वी हैव टू प्रैक्टिस 1 mark प्रॉब्लम टू. शैल वी मूव फॉरवर्ड बेटा? प्लीज टेल मी एवरीवन, शैल वी मूव फॉरवर्ड? Grashof number is in case of free convection, that is natural convection. Okay. Oh my god, another beautiful problem in front of you. 2 mark problem with beautiful diagram and beautiful equation beta. Beautifully formulated by your sir गौरव श्रीवास्तव सर. सो बेटा कम ऑन एवरीवन, खुश कर दो मेरी इस प्रॉब्लम को सॉल्व करके आप सभी. आई विल स्टार्ट टाइमर आफ्टर 30 सेकेंड. If you feel any data is not there, immediately ask me. There may be a chance of typing error. Like first question में हमने गलती से convex टाइप कर दिया था. So you can't solve that problem with convex if convex is there and then F12 is missing. But ऐसा 20 क्वेश्चन में एक प्रॉब्लम में हो सकता है. Chances are very low, but still if you feel that any data is missing, immediately ask me. Come on, beta, everyone. Okay, so now I'm starting timer number one. Try to formulate it with a step by step, and it's very easy problem. Also, if you know everything, then it can take less than 2 minutes or approximately 2 or 3 minutes max. Last minute, beta. Second. Last 10 second. I'm starting timer number two. And also one beautiful hint that here directly you will get average heat transfer coefficient because average Nusselt number calculation equation is there. Just you have to calculate that H, and after H you know the formula for convective heat transfer. That is from plate to surrounding H delta T. It will give you answer. Just Javel 299 0.9, absolutely correct बेटा. Congratulations, I am happy but not very happy क्योंकि अभी बाकी बच्चा लोग जवाब नहीं दिया है. Everyone बेटा please give me answer. By solving these problems, इनके सॉल्व करने के बाद यू विल फील कि हाँ, आप कॉन्फिडेंट फील करोगे, हाँ मैं कैल से चलाता हूँ तो मुझसे सही होते हैं क्वेश्चन. सो आई होप यू ऑल गिव मी राइट आंसर इन जस्ट फर्स्ट अटेम्प्ट. पहले अटेम्प्ट में ही सही आंसर देने की कोशिश करने का. Those who unable to solve within given time, after 10 or 15 days, see that this lecture again and try to solve it again within given time. Okay, जिनसे अभी सॉल्व नहीं हो पाता है दिए हुए समय में, डोंट बी डिमोटिवेट. डिमोटिवेट होने का रिक्वायरमेंट नहीं है. आफ्टर 10 और 15 डेज फिर से इस लेक्चर को देखिए और देख के वापस से प्रैक्टिस करिए, वापस से सॉल्व करने की कोशिश करिए. Okay, try to solve it again after 10 or 15 days. Okay beta, so now please pay attention here. I am solving it. This is another beautiful and easy problem. Okay, so in a large room, air is present at 25 degrees Celsius and 1 atmospheric pressure flows over a flat plate at 35 meter per second as shown in the figure. Okay, bhaiya. So here in a large room, air is present at 25 degrees Celsius. So that means you have T infinite, and T infinite is given as 25 degrees Celsius. Immediately, I am going to convert this into Kelvin. In Kelvin, you can write as 298 Kelvin. Okay, so in a room, air is present at 25 degrees Celsius and the pressure is also there, 1 atmospheric. 1 atmospheric pressure can also be written as 101.325 kilopascal, and also velocity is there. So this air is flowing at a rate of flow over a flat plate and at a rate of 35 meter per second. U infinite is 35 meter per second. Okay. Now, the plate is 100 centimeter long. That means total length of the plate is 100 centimeter. That means I can write here 1 meter. In SI unit, I can write 1 meter. Now, and this plate is maintained at 60 degrees Celsius. That means my whole plate is maintained at 60 degrees Celsius. In Kelvin, 273 plus 60, it will give you 333 Kelvin. जस्ट चेक इट बेटा, इज इट करेक्ट. हालांकि यहाँ पे आपको कन्वर्ट करने का रिक्वायरमेंट नहीं था. ओनली इन केस ऑफ रेडिएशन यू हैव टू कन्वर्ट डिग्री सेल्सियस टू कैलविन. तो डेल्टा टी कन्वर्जन ऑफ डिग्री सेल्सियस एंड कैलविन बोथ आर सेम. ओके, नाउ प्रॉपर्टीज ऑफ द फ्लूइड रिमेन्स कांस्टेंट. फ्लूइड की प्रॉपर्टीज कांस्टेंट है ओवर फ्लैट प्लेट अंडर स्टडी ऑपरेटिंग कंडीशंस. स्टडी स्टेट में सब कुछ हो रहा है, एवरीथिंग इज गोइंग इन स्टडी स्टेट मैनर. प्रॉपर्टीज ऑफ एयर अंडर गिवन कंडीशंस आर विस्कोसिटी ऑफ एयर इज गिवन. Viscosity of air is given 1.906 into 10 to the power minus 5. Pascal second is also SI unit, that is kilogram per meter per second. Next, K is there 0.028. K is 0.028. Again, this is in SI unit, watt per meter per Kelvin. Next data CP. CP is given in kilojoule. So immediately convert this CP into joule. 1007 joule per kg per Kelvin. Okay, bhaiya. Beautiful. And now the given, for the given condition, average Nusselt number can be calculated by. Here it is clearly mentioned beta that NUL can be written as HL by K. If this is HL by K, that means if you are going to calculate this Reynolds number, then in this Reynolds number you can write L U infinite rho by mu. Rho by mu. And you know about Prandtl number. Prandtl number is Cp mu by K. This is Cp mu by K. So first I am going to calculate a Reynolds number and Prandtl number separately. So L U infinite rho by mu. L is 1 meter. U infinite is 35. Density rho. Oh my god, density is not there. So density, this is air, so density's formula you know that P m average by RT. So if you are going to take the value of R as 8.31451, then pressure must be in kilopascal, that is 101.325 kilopascal. Temperature must be in Kelvin. So air is at 298 Kelvin and average molecular weight of air is 28.84. So after calculation you will get density and it will come 1.1794, 1.1794 kilogram per meter cube. Now, after obtaining this, put here 1.1794 and upon viscosity is there 1.906 into 10 to the power minus 5, and after solving it will come 21657, 2165739.77. This is your Reynolds number, beta. Similarly, you can calculate Prandtl number. Prandtl number is Cp mu by K. Maybe in your examination Prandtl number की value सीधे दिया हो, your to save your time. So 1007 into mu 1.906 into 10 to the power minus 5 upon K 0.028, and after solving you will get Prandtl number as 0.6855. Absolutely correct, beta. 0.6855. Now, by last equation, you can easily calculate H bar. So H bar can be written as, you can see here, beta. This L by K, you can write in RHS as K by L. Okay. So K by L. K is how much? 0.028. K by EL. Okay. Prandtl number to the power 1 by 3. So Prandtl number 0.6855 to the power 1 by 3. Next, inside bracket 0.037, 0.037. Reynolds number to the power 0.8. So Reynolds number is 2165739.77 to the power 0.8 minus 870. मे बी यहाँ आपको दिख रहा है कि नहीं दिख रहा है, या दिख रहा है then okay. Now beta, after solving you will get your H bar and this H bar will be 85.471. Yes beta, absolutely correct, 85.471, and you will get this in SI unit. This is your H bar. Once you got H bar, then you will get your answer, because Q can be written as H bar into A into TW minus T infinite. So this H bar is for 85.471. Now what is area beta? If this is your flat plate, so it is written that in Z direction take unit width, that means 1 meter, and its length is 1 meter, that means 1 into 1. 1 into 1 will give it its area, and the delta t you can take directly in degrees Celsius or in Kelvin, it's your choice. Okay, so 333 minus 298, that means 35 here, and after solving you will get 2991 approximately, थोड़ा बहुत आगे पीछे हो सकता है, 2991.4 8 watt. In your problem, want answer in up to 2 decimal place, then this will be your answer. Tell me beta everyone, is it crystal clear to all of you beta? Everyone beta, shall we move forward to problem? Next problem. Everyone beta, come on everyone beta, you are all enjoying, सभी को मजा आ रहा है ना प्रॉब्लम सॉल्व करने में? You are feeling more and more confident after each and every problem now? Okay, and fantastic, mind blowing, super. I am moving to, oh, it's very very easy. Tell me बेटा, ये सेम क्वेश्चन दो बार हो गया क्या? पहले भी रियलाइज था, अभी भी रियलाइज है क्या? ओ, ये तो सेम टू सेम दो बार हमने टाइप मार दिया. यहाँ कुछ और लिखना था यार. कौन सा नंबर था? याद आया. रुक जाओ, अभी लिख देते हैं, चेंज कर देते हैं। इट्स टाइपिंग, टाइपिंग एरर नहीं है, कॉपी पेस्ट में वो वाला गलत फाइल डिलीट मार दिया हमने, नो प्रॉब्लम। सी हियर आई वांट टू नो क्रेड्स नंबर। वेट, yeah, grades number is defined as, अरे बेटा अभी रुक जाओ, ऑप्शन तो आने दो, ऑप्शन तो आने दो। हम्म, now tell me बेटा, A B C D which one is correct? Everyone, it's very easy. So Renault Prandtl into D by L. Renault Prandtl is known as Packlet number. This is known as Packlet number, and Packlet number into D by L is known as Grads number. Absolutely correct. Okay, beta. So now see beautiful problem number 8. Another you can take this as a 1 mark or 2 mark problem. It's very easy. Come on. So I'm starting your timer. Come on, beta, everyone. Try to give me answer within time. Last 90 second, beta. Come on, Vibhas, Chinnari, Ziavel and all. Chetan, Dilip, Rao, Manthan. सभी लोग लगाओ बेटा. Come on. 1 minute. Absolutely correct. 4.8 is the right answer. Javel, Chinnari, both correct. Good beta. Very good, Vivash. I'm not going to give second timer for this problem. Very good, Manthan. Everyone, congratulations. Very good, beta. Very good. Last 12 second. Very good, very good. Last 5 second. Okay, time up. So it's very, very, very easy problem. It's very easy problem. See, two equal thickness plates with equal heat transfer areas with thermal conductivity 4 and 6 watt per meter per Kelvin respectively. Like if this is my first plate and this is my second plate, so both are of equal thickness. Like here if thickness is x, here also thickness is x, and its thermal conductivity is 4, its thermal conductivity is 6. This is thermal conductivity K value of both plate K1 and K2. are joined together to form a single plate of double thickness. You can see beta, I am joining this, and after joining I will get a plate of double thickness. The equivalent thermal conductivity. Now he want to know that if we want to write just one K equivalent, then what should the value of K equivalent for this composite plate in same SI unit watt per meter per Kelvin. Here beta, you know now beta, that sum of all resistances can be written as L1 by K1A. So here L1 by K1A plus L2 by K2A, and to make it equivalent to one single composite wall resistance. So here your case 3 L3 upon K equivalent A. A cancelled. L1 is X, K1 is 4, X by 4, L3 yani ki it means in the equivalent case it's 2x upon K equivalent. X cancelled. In LHS you will get 1 by, sorry, this is K2 is 6 not 4, this is 6. Okay, so you will get 1 by 4 plus 1 by 6 equals to 2 by K equivalent, and after solving it you will get 4.8 watt per meter per Kelvin. There may be in this problem ऐसा भी हो सकता था that he want to know just equation. So equation should be written as what? 1 by L1 by K1, A cancelled out, L2 by K2 equals to L3 by K equivalent. So here after cutting 1 by K1, 1 by K2, and here you will get 2 by K equivalent. Okay, so after taking LCM you can write K1 plus K2 by K1 K2 equals to 2 by K equivalent. So K equivalent can be written as 2K1 K2 upon K1 plus K2. ये भी आपसे पूछ सकता था बेटा, केवल ये इक्वेशन. Okay beta, everyone crystal clear? Shall we move forward to my next beautiful problem? Okay, so another beautiful problem of 2 mark with beautiful concept made by me. I hope you all will get answer. So I will start timer after 30 सेकेंड बेटा. बहुत ही बेहतरीन क्वेश्चन आपके लिए बनाया है ये, इससे आपका बहुत ही बेहतरीन वाला कॉन्सेप्ट क्लियर होने वाला है, and you will feel more confident after solving this problem. I will start timer after 30 seconds. Solve it ASAP. Okay, but I am starting timer. Timer number 1 is started already. If you remember my derivations, then definitely you can crack this problem. MTO numerical batch formed and already shared batch code in chat section of heat transfer operation numerical batch. So request with that code अपने आप को फटाफट ज्वाइन करा लीजिए. Okay, but I'm starting second timer. No, beta Chinnari, not correct. Your answer is not correct. If you forget my derivation and if you don't want to revise derivations, then definitely you can't solve this problem. आपसे ये solve नहीं होगा. And I derived this equation while discussed ब्यूटीफुल पी वाई क्यू. एक पी वाई क्यू आया था, उसमें एक टर्म यूज हुआ था फॉर द केस ऑफ ओवरऑल हीट ट्रांसफर कोफिशिएंट. इफ यू रिमेंबर, आई थिंक दैट वाज पी वाई क्यू ऑफ 2016, मे बी 2016 का वो पी वाई क्यू था आई थिंक. सो ये उसी से रिलेटेड प्रॉब्लम, लेकिन उसमें कुछ और पूछा था. दैट जस्ट वांट टू नो एच, बट हियर लिटिल बिट डिफरेंट. Okay, okay, okay. So anyone wants more time or explanation for my side? Because this is our today's last problem. More time? Okay, I can give you more time. Just wait. I am saving, refreshing, and giving it another 2 minutes. 2 minutes, Javel. Come on, beta. If you remember that derivation, आप आसानी से कर सकते हो इसे. 4.7 is totally wrong. Totally wrong, Chetan. How average temperature difference along the plate is 4.7? Come on, beta. Come on, everyone. Everyone. No, beta. Javel. 253.047 is not correct. You had done any beautiful mistake, I think. Wait, I'm checking. ऐसा तो नहीं कि हमने ही कुछ गलत कैलकुलेट कर दिया है. No, I am right. You are wrong. Okay, last 24 seconds, beta. After that, I will explain. It's very easy problem beta, just need one beautiful concept. How to take average beta, you all know ना how to take average. तो क्यों नहीं लगा पा रहे हो इसे? Why you all are unable to solve this problem? चलो कोई बात नहीं, नो प्रॉब्लम, सी हियर, ध्यान देंगे यहाँ पे सभी लोग. कहीं पे डाउट होगा बेटा फील फ्री टू आस्क मी. ओके. So in this problem, on a 1.5 kilowatt heater, a glass plate is constructed with an electrically conducting film which produces constant heat flux. That means आपके पास एक हीटर है बेटा, you have a heater जिससे लगातार एक constant heat flux निकल रहा है. और heat flux कितने का निकल रहा है? जिसमें अरे हीटर जो आपका 1.5 किलोवाट, यानी कि ये हीट फ्लो रेट, कांस्टेंट हीट फ्लक्स वाला हीट वो आपका सरफेस बन गया है, जिससे रेट ऑफ हीट ट्रांसफर इज गिवन एज 1.5 किलोवाट, दैट मीन्स 1500 वाट. ओके. दैट मीन्स इन दिस प्रॉब्लम वी हैव द वैल्यू ऑफ क्यू डायरेक्टली. हमेशा क्यू कैलकुलेट करना होता था. इन दिस केस आई हैव द वैल्यू ऑफ क्यू. ओके. नाउ द प्लेट इज 15 to 50 सेंटीमीटर. That means यहाँ आपका कोई हीटर था बेटा, and one beautiful plate is above that heater, and this plate is of 50 into 50 by 50 centimeter. Okay, this is 50, this is 50. Okay, placed in an air stream. Here air stream is going there, and air stream is at 37 degrees Celsius. It is already given in our problem. Okay, so this is your 50 by 50, 50 by 50 plate, and above one beautiful heater, and that heater is going to give energy to it, and that Q is 1500 watt, and air is also flowing and available at 1 atm, and 1 atm 37 degrees Celsius, velocity 10 meter per second, and at 37 degrees Celsius. Okay, that means this is your beta T infinite. Okay. Now wall temperature is not there, so I am mentioning wall temperature is TW. Now properties remains constant with steady operating conditions. Data for air under given condition, kinematic viscosity and K, and Prandtl number is there. Kinematic viscosity 28.2 into 10 to the power minus 6. Kinematic viscosity 28.2 into 10 to the power minus 6 meter square per second, and K 0.035. Thermal conductivity is there 0.035 watt per meter per Kelvin. Prandtl number is directly given 0.7, and one beautiful equation for local Nusselt number is there, and that is NUX given as 0.453, REX पे 1/2, एंड प्रॉन्टल नंबर पे 1/3. बेटा आपको याद है हमने आपको एक पढ़ा था कांस्टेंट वॉल फ्लक्स का केस, एंड इन दैट केस हमने आपको बताया था कि एवरीथिंग इज कन्वर्टेड, एंड कितना टाइम्स हो रहा था उस समय आपको याद है? हाउ मच टाइम्स? इफ यू आर गोइंग टू टेक एवरेज नसल्ट नंबर, नो ना 2 टाइम्स नहीं बेटा, दैट वन इज डिफरेंट, दैट वन डिफरेंट बेटा, वो लेमिनार वाले में था आपका, वो अलग था. एक हमने कांस्टेंट वॉल फ्लक्स आपको पढ़ाया था, अपने नोट्स में चेक करना. एंड ऑल्सो एक आपका PYQ का पूछा हुआ क्वेश्चन जिसमें 3/2 आंसर आया था, आपको याद आ रहा है? 3/2 हीट ट्रांसफर कोफिशिएंट का था, 3/2. यस. सो उन्हीं दोनों कॉन्सेप्ट को लेकर के इसे सॉल्व करने का है, और जस्ट वेरी इजी, ये कुछ भी नहीं है बेटा, इट इज नथिंग, जस्ट सी बेटा हियर. He just want to know because आपको पता नहीं, you know ना, that this 37 degree Celsius is here, not here, here, everywhere on your plate. Delta T will be different. Delta T आपका सेम नहीं होता है, Delta T is different. And if you want to take your H average, then you can take TW minus T infinite. TW minus T infinite. या बेटा मंथन, उसी तरह का ये प्रश्न है. So TW minus T infinite. So is TW minus T infinite is same to same everywhere, beta. Just tell me yes or no. This is same over entire plate or not same? Not same now. But you are taking this, and if you are taking this, then by multiplying A into H bar, you will get Q. You will get your Q. This is your case now. Just tell me yes or no. Is it correct? Okay. But here, the problem is different. Here, I want to know that what is the value of TW minus T infinite average over entire plate. अगर हर जगह आपका अलग अलग टेम्परेचर है, everywhere temperature is not same to same on that delta T is not same, then just I want to know that what is the value of this TW minus T infinite. Just tell me beta, is it clear? क्वेश्चन क्लियर हुआ मेरे प्यारे बच्चों? जस्ट टेल मी यस सर. इज इट क्रिस्टल क्लियर टू ऑल ऑफ यू बेटा? कम ऑन, जल्दी से बोलने का बेटा, थोड़ा जोश में. एवरीवन एवरीवन बेटा, if you have any doubt just feel free to ask me beta. Okay, now for any type of average beta, what you have to do, it's very easy ना. क्या करते हो किसी भी केस के लिए जब आपको निकालना होता है? इट्स वेरी इजी. क्या करते हो? याद है वो फॉर्मूला? दैट फॉर्मूला for average यार. our plate length is 0 to L. Oh no यार बेटा, that is arithmetic mean. Here you do no need to take arithmetic. यहाँ arithmetic mean नहीं लोगे. It will depend upon your given equation and the formula 0 to L dl dx, that will give you 1 by L. You remember? And integrating this 0 to L, which one? This TW minus T infinite you have to integrate. यही तो आपका है बेटा. This is your problem. Just tell me beta, is it clear? This equation is clear to all of you? Just tell me beta. अगर यहाँ तक clear है, then I will move forward. If you all are clear till now, then I will move forward and will give you another beautiful concept. Everyone, tell me beta. सभी लोग बताएंगे. Everyone, each and every student. I want comment from each and every student beta. If everyone clear, then I will move forward. सभी लोग, everyone. I'm explaining again beta Chetan. Don't worry beta. See here. It is nothing. Suppose you have to take average. I'm just giving you an example. Okay. If you want to take average of H bar. So how you are going to take this? 0 to L Hx dx upon 0 to L dx. And from here you will get H bar as 1 by L 0 to X Hx dx. ये आपको रिमेंबर है बेटा? You remember this? So there, in this case, you want to take average of pH. Here you want to take average of temperature difference. What is the difference between these two? Analogous in nature ना. देख लो यार, दोनों तो सेम है. क्या है दिक्कत इसमें? अरे एवरेज लेने का तरीका आपको पता है, so you can take average for any case. गेट में बेटा सीधे सीधे मिठाई नहीं आती है सारी की सीधे उठा के खा जाओ. थोड़ा सा आपको प्रैक्टिस करनी पड़ेगी. ठीक है, फंडामेंटल्स अपने क्लियर रखेंगे. बट डोंट वरी, नहीं लगा भाई, डोंट बी डिमोटिवेट. आज लगाने के बाद अगर वापस से कभी मिला और नहीं लगाओगे तब गलत बात है. ठीक है, शैल वी मूव फॉरवर्ड नाउ? क्या अभी आगे बढ़ सकते हैं? एवरीवन बेटा प्लीज अलाउ मी. अगर क्लियर है देन प्लीज अलाउ मी, अदरवाइज आस्क मी अगेन एंड अगेन. क्लियर सभी को? एवरीवन बेटा प्लीज टेल मी. एवरीवन क्रिस्टल क्लियर टिल नाउ? ओके, फैंटास्टिक. नाउ बेटा सी, what is the value of TW minus T infinite? I don't know. It is not given in our problem. Everywhere, nothing. But one thing is there, that is Nusselt number. You know na, Nusselt number can also be written in terms of delta T. Just tell me yes or no. Just tell me yes or no. आपको याद है? You had remember Nusselt number can also be written as delta T. Just tell me yes or no beta. You can write or not. और if you don't know, wait, ये क्या आ गया भैया? प्रॉब्लम नंबर 2. एक मिनट वेट बेटा. ओह, this is problem number 2. So copy paste. I think 5 pages enough. Okay, so here now Q by A. Can you tell me beta, what is Q by A? It can be written as H X into TW minus T infinite. Just tell me yes or no. at that local, this tw minus t infinite at that local place, at that local place. This is local, tw minus t infinite is local. देखो आज इसको local बना दिया. This is local. Okay, because you are taking hx local. Is it clear? Is it clear to all of you, beta? And here this tw minus t infinite, this is also local. That means at any x location. X is what? From leading edge, distance from leading edge. Is it crystal clear to all of you, beta? Shall we move forward? Tell me, everyone. I have one beautiful formula given, that is hx into x upon k, that is local Nusselt number, and that becomes equals to 0.453. 0.453, and Reynolds number you can write as x u infinite. In this question, kinematic viscosity is given. Yeah, so I'm writing Reynolds number in terms of kinematic viscosity to the power 1 by 2, that means 0.5, and a Prandtl number to the power 1 by 3. Now you can see beta here, you can see here that here in place of this hx, in place of this hx, you can write this whole equation, this whole, that means 0.453 k by x. I'm not writing x here. Okay, k by x, x is in denominator. Okay, I'm writing x is in denominator, and here u infinite by nu to the power 0.5 and x to the power 0.5. I'm taking this x outside of this bracket, and Prandtl number to the power 1 by 3, and then tw minus t infinite local. Now you can see here beta, it will come 0.453 and k into u infinite by nu to the power 0.5 and Prandtl number to the power 1 by 3, and here you will get x to the power minus 0.5 and tw minus t infinite x. This is your q by a. Just tell me, is it correct? Is it correct? You can see beta, u infinite, nu, Prandtl number, and also it is written there that a constant heat flux is there. That means q by a is also constant. Only one variable, this q, this x. Only one variable, this x, and second variable tw minus t infinite x. So here you can write this tw minus t infinite x as q by a into 0.453 into k into u infinite by nu to the power zero point 0.5 Prandtl number to the power 1 by 3, 1 by 3 and into x to the power zero point 0.5, because here x minus 0.5 तो उधर ले जाओगे बेटा, then it will convert it into x to the power 0.5. Just tell बेटा, कुछ मिस तो नहीं हुआ? Everything is there. सब कुछ लिख दिया? Just tell me yes or no. Please tell me, everyone, is it correct? Everyone crystal clear? After solving this, I will also give you a beautiful short trick to solve this problem within 1 minute. I will give you a short trick. Okay. So is it crystal clear till now? Now you have to integrate this term, and this whole part is constant beta. This whole part is constant. आप चाहो तो just calculate this constant term directly. So no need to write it again and again in your integration. बिकॉज दिस टर्म इज कांस्टेंट ना, तो बार बार इंटीग्रेशन में क्यों लिख के परेशान हो गए यार? कैलकुलेट कर दो, करो कैलकुलेट. एवरीवन प्लीज कैलकुलेट दिस कांस्टेंट. q is 1500 and what is a area? कितना था? What is the dimension of my beautiful plate? 50 by 50 centimeter. That means 0.5 into 0.5 will give you 0.5 is square into 0.453 into k. What is the value of k? 0.035, 0.035. And u infinite, where is u infinite? Where are you, u infinite? Wait, कहाँ गया भाई? Yeah, 10. It is 10 meter per second. You can see 10 meter per second. Okay, this is what, कहाँ तक पहुंचे थे भाई, ये u infinite, and upon new kinematic viscosity value 28.2, 28.2 into 10 to the power minus 6 to the power zero point 0.5, and Prandtl number directly given 0.7, so 0.7 to the power 1 by 3. Can you tell me beta, after calculation, what will you get? 10 divided by 28.2, 1 2 3 4 5 6 square root into zero point 0.7 to the power 1 by 3 into 0.035 into 0.453 into zero point 0.5 square reciprocal into 1500. Is it 715.721? प्लीज कोई बच्चा कंफर्म कर दो. वेरी गुड मंथन. 715.721. That means this equation can be written as t w minus t infinite local equals to 715 point, because बहुत लंबी वैल्यू है तो up to 2 decimal place you can take 0.5. This is your equation number 3. So now by equation 1, that equation was tw minus t infinite average. You want to know this one beta. So 1 by L 0 to L and 715.72 into x to the power 0.5 dx. X to 0.5 will give you x to the power 1.5 by 1.5, because here integration, you have to perform integration. So 1 by L 715.72 into x to the power, and after taking limit, x will be converted into L. X will be converted into L. So L to the power 1.5 by 1.5, or you can write L cancelled and you will get 715.72 by 1.5 and multiplied by L to the power 1.5, and L to the power 0.5. The value of L was 0.5. So 715.72 upon 1.5 into 0.5 to the power 0.5. But please tell me, after solving, what will you get? 337.394. Is it correct beta? Tell me everyone beta. So concept is crystal clear to all of you. Is it crystal clear beta? Come on everyone, please tell me. Is it crystal clear? Now, another thing I want to show you beta. That equation, if you can see, then you can see here you got just one term. This is 1.5 term in denominator, and everything was in denominator. Here you can see. So just in this, after integrating, this one is converted into L pe 1.5 by 1.5. Am I correct beta? Just tell me yes or no. Please confirm me. Is it correct? After integration यही तो आया ना. You got L to the power 1.5 by 1.5. Everyone clear? So this L to the power 1.5 can be written as what? L pe minus 1.5 in denominator. बोलो समझ में आ रहा है कि नहीं? You can write it as L into L to the power 0.5. L into L to the power 0.5. इस वाले इक्वेशन को देखो, प्लीज सी दिस इक्वेशन. यहाँ ज़्यादा बेटर समझ लोगे डायरेक्टली. ओके, So this x will be L, and it will give you, this is x पे 0.5। यहाँ से एक मिनट इससे मत देखो, नीचे वाले से देखो, और जल्दी एक बात जो बताना चाहते हैं समझ जाओगे। इस वाले को देखो, डायरेक्टली यहाँ से देख लो, अदरवाइज फिर से डिराइव करना पड़ेगा, टाइम लगेगा, इसलिए इसी में आपको हम दिखा देते हैं। सी बेटा, दिस इक्वेशन, दिस इज इक्वेशन q by a। इज इट क्लियर? यार करना पड़ेगा, इससे भी सीधे आप नहीं देख पाओगे, दो लाइन यहाँ लगेगी नीचे, डायरेक्टली नहीं दिखेगा। चलो आपको एक्स्ट्रा में दिखा देते हैं क्योंकि ज़रूरी है। एक्स्ट्रा एक छोटा सा पार्ट देख लो, एक्स्ट्रा, क्योंकि डायरेक्ट वाला इक्वेशन आ ही नहीं रहा, क्योंकि वहाँ से फिर दो लाइन करनी पड़ेगी। ठीक है, यू गॉट इक्वेशन, दिस इक्वेशन सी टी डब्ल्यू minus t infinite, I am directly writing here, and this becomes equals to 1 by L 0 to L q upon a into 0.453। बहुत ही ब्यूटीफुल आपको कंक्लूजन देने वाले हैं बेटा फ्रॉम हियर। इवन यू नीड नॉट टू डेराइव दिस इन योर एग्जामिनेशन, जस्ट लाइक जैसे लेमिनार वाला केस आता है, आप डायरेक्टली लिखते हो तो टाइम होता है एच बार, एग्जाम में आप डिराइव तो करते नहीं हो। चाहे हमने जो कल भी प्रॉब्लम आपको लगवाया था या लास्ट लेक्चर में, इन दैट लेक्चर आपने सेम टू सेम, यू हैड सीन सेम टू सेम ना। दिस इज योर केस। सो आफ्टर सॉल्विंग, फुल सॉल्यूशन आई एम शोइंग यू हियर बेटा, टोटल सॉल्यूशन आपको दिखा रहे हैं यहाँ पे। इट कैन बी रिटन एज यल क्यू बाई दिस यल into A into 0.453 into K into U infinite by nu 1 by 2 Prandtl number 1 by 3, and here you can write L to the power 3 by 2, that means 1.5 by 1.5। आप चाहो तो 1.5 लिख लो, ज़्यादा बेटर लगेगा। 3 by 2 की जगह 1.5 लिख लो। 1.5, okay। Now in next line, I want to write it like q by this L as L, सेम टू सेम वैसे ही रहने दे रहे हैं, A 0.453, and I am taking one L here बेटा, L u infinite by nu to the power 1 by 2, एंड अगर नीचे आपने L by 1 by 2 लिया, दैट मीन्स नाउ न्यूमरेटर बिकम्स L टू द पावर हाउ मच बेटा, कैन यू टेल मी? L to the power how much? Tell me everyone. No बेटा, it's 2 ना, it's 2 ना, ये L to the 0.5, that means ऊपर जाएगा 2 minus 0.5 will give you 1.5 again, it's 2 ना, L square। Is it clear बेटा? Prandtl number to the 1 by 3 1.5। ऐसे मिस्टेक ना करें, छोटी सिली मिस्टेक। ओके, नाउ आई जस्ट वांट टू राइट q by a इक्वेशन फ्रॉम हियर। बहुत ही बेहतरीन चीज आपको दिखाने वाले हैं रिजल्ट में। ठीक है, so this equation, with the help of this equation I am now going to write q by a, q by a, see this L and this L will be cancelled by L square, but काट नहीं रहे डायरेक्टली। अभी यहाँ देखो, finally you will get q by a as k, लिखना भूल गए थे क्या? पॉइंट यहाँ k भी है, k is also here, this L will converted, now this is your just here, so q by a I am going to write this q by a beta, so you can see this is L by k, so in LHS it can be written as k by L, so 1.5 that parameter multiplied by k by L and multiplied by 0.453 and into, you can see beta, this is nothing but Reynolds number at x equals to L. Okay, so this is nothing but REL to the power 0.5, that means 1 by 2, and Prandtl number to the power 1 by 3, and here TW minus T infinite bar. Same to same now? Just tell me yes or no. Now see here beta, see this equation. Mm, 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 mm. Yeah, this equation. This is your Hx and this is your Hx. Am I correct? Just tell me yes or no. This is your Hx. Okay. If you are going to put x equals to L, what will you get? This as k by L, and this L to the power zero point 0.5 will give you REL. This is Prandtl number 1 by 3. Am I correct, beta? Just tell me yes or no. Yes. So here you can write this whole as 1.5, that means 3 by 2 H at x equals to L. This whole R H as x equals to L into TW minus T infinite bar. You can see with one beautiful equation. That means if you know this equation, that in this case in place of H bar, because beta अगर आप ये लेते हो C, if you are taking this H bar, so with this H bar you have to take TW minus T infinite. You are not going to take TW minus T infinite bar. You are not going to take average temperature difference or entire surface. You are writing H bar here. But if you are going to write this as average, then in that case, in place of that H x, you can write 3 by 2 at H x equals to L. Okay, beta, is it clear to all of you? Just tell me yes or no. Just tell me yes or no, beta. Is it crystal clear? So from here, you can write TW minus T infinite bar as 2 by 3 Q by A into H at x equals to L. This was your formula. जो आपने अभी कैलकुलेट किया बड़े में, यही था और कुछ नहीं था. Is it crystal clear, beta? Just tell me yes or no. So अगर आपको ये याद है, you have remembered this term, because in your examination they will give you in 99% cases Reynolds number to the power 0.5 case. So if you remember 3 by 2 Hx equals to L, then within 1 minute. Otherwise, by this way you can also solve it in calculation is little bit more, but you can solve it in 3 minute approx. Okay, shall we move forward to next problem number 10? We have still 12 minutes left. So ये वाला लगा के दिखाओगे क्या? This one, 10th number बेटा. The temperature difference at the trailing edge. This time I want to know temperature difference at the trailing edge, and don't want to know average temperature difference along the entire plate. I just want to know temperature difference at the trailing edge. So फटाफट देखो, ट्राई करो. अब यही अगर एग्जाम में आपको घुमा के दे देता, देखो यहाँ पे लिख देता आपको कि दैट दिस इज टी डब्ल्यू माइनस टी इनफाइनाइट बार. ओके, अगर आपको ये लिख देता टी डब्ल्यू माइनस टी इनफाइनाइट टू द पावर, देन इन दैट केस डायरेक्टली आपके दिमाग में क्या आता, यू स्टार्ट थिंकिंग दैट इन दिस you they will give you like this, h bar t w minus t infinite bar, and what is the value of this? So आप डायरेक्टली लिख देते, in that case 2h x equals to l, and you will be wrong, because h 2h x equals to l you can write there if tw minus t infinite is there. Tw minus t infinite bar is not there. Is it clear? Just tell me, ये concept clear है? Is it crystal clear? This is one more problem beta. Yes, very good. So now please solve it. Final problem number 10. Come on. Everyone, after that, good night, good night. After that, good night. I am giving you 2 minutes, 2 minutes, because 10 minutes left. 100 सेकेंड बेटा. एक्स्ट्रा टाइम नहीं देंगे आपको. आई एम नॉट गोइंग टू गिव यू एक्स्ट्रा टाइम. 40 सेकेंड बेटा. टाइम अप. 253.047. अगेन रॉन्ग है. मंथन 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 रॉन्ग है. देखो बेटा, for this case, you have to use just this equation number 2, because this time local temperature difference you want to calculate. Directly by using this formula, it will give you your answer. So for second part, by equation, that means for problem number 10, by equation 2. Equation 2 was, I am writing again, कहाँ गया by 2, yeah, 2 was TW minus T infinite x, आप भी मिला लेना, Q upon A into 0.453 K U infinite by nu to the power 1 by 2 Prandtl number to the power 1 by 3 x to the power 1 by 2. So now Q was 1500 and you want to know at x trailing s. Trailing s means x equals to 0.5 meter. Okay, trailing s, end of the plate. So into 0.5 to the power 1 by 2 upon area 0.5 square 0.453, and how much k was 0.035 na, yeah, 0.035. U infinite was 10, nu was 28.2 into 10 to the power minus 6 to the power 1 by 2 and 0.7 to the power 1 by 3. अगर आपसे ये प्रॉब्लम पूछता तो यू कैन सी बेटा इट इज़ वेरी वेरी इजी. ये तो विद इन 1 मिनट वाला था, अप्रॉक्सीमेटली 1 मिनट और 90 सेकेंड. ओके, if trailing edge, you want to know what is the value of temperature difference at trailing edge. After calculating, tell me beta how much. First, अगर ये पूछता बेटा तो इट विल बी वेरी इजी फॉर यू, एंड लास्ट पार्ट इज ऑल्सो ईजी, एंड यू कैन सेव योर टाइम इफ यू रिमेंबर। हमने आपको रिमेंबर कराया, अगर 3/2 आपको याद है इन दैट केस कि इसमें ऐसा होता है, तो 0.5 पे 2 टाइम्स आता था एच बार, यू गॉट टू टाइम्स ऑफ एच एक्स इक्वल टू एल एच बार इन लेमिनार केस, एंड इफ सेम थिंग बट you are going to write TW1 infinite bar, then everything will be different. Yeah, absolutely correct. It's 506.09 1 degree Celsius. If you want answer up to 2 decimal place, so 506.09 degrees Celsius. Tell me everyone beta, is it crystal clear to all of you beta? फटाफट बताएंगे सभी लोग फटाक से बताओ भाई, इज इट क्रिस्टल क्लियर बेटा? नो डाउट्स, एवरीवन क्रिस्टल क्लियर? सो बेटा यू ऑल एंजॉय टुडे सेशन, मजा आया सभी को? एवरीवन, everyone enjoy today's session? Okay, very good beta. So don't forget to revise daily. I must do my revision 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 daily. अगर आप बेटा रोज रिवाइज करोगे, if you are going to revise every day, then definitely you will get your dream rank in GATE. Okay. So for today, that's it. And a very happy good night to all of you. Take care, beta. Okay. You're all welcome, beta. सबने enjoy किया? Everyone enjoyed session? And don't forget to request with patch code for mass transfer operation numerical patch. Okay, everyone clear beta? Okay beta, very happy good night to all of you. Very happy good night. Take care beta. Anyone, any doubt? Everything is clear beta? कुछ पूछना नहीं चाहता है कोई बच्चा? Everyone crystal clear in all 10 problems? I will wait for next 1 minute. After that I will end this session. If you have no doubt, you can leave the session beta. I will wait for next 30 more seconds. If anyone want to write their comment, I'm waiting. Okay, beta. So now I am ending the session. All the best once again to all of you, and a very happy good night, beta. Take care. Okay, bye bye.